purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 1, Investigating Volume of Solid Figures. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 1. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. This unit has two AKS. Under the AKS, you will find the Indicators of Achievement, or IOAs. You will also see that we have provided you with the state coding at the end of the IOAs, so that if you are looking up resources on the Georgia DOE website, you are able to find the IOA that is related to the GCPS IOA. Unit 1 focuses on the volume of solid figures. You will notice that AKS 5 MAD8 focuses on both volume and properties of polygons. In Unit 1, you will only focus on volume for this AKS. You will not focus on properties of polygons until Unit 7. The magnitude of the numbers used are limited to previous understandings in 4th grade related to the multiplication of 2-digit by 2-digit whole numbers. IOA 8C focuses on students exploring the volume of solid figures from realistic situations by packing them with no gaps or overlaps. Students determine that a solid figure packed with n unit cubes is said to have a volume of n cubic units. Students investigate authentic problems involving volume to make sense of this concept. IOA 8D focuses on students describing and reasoning how the volume of a right rectangular prism can be found by multiplying the area of the base times the height is true. This connects to students' previous understanding of finding the area of composite figures from 3rd and 4th grades into the context of volume. Specifically, students cover the bottom of a right rectangular prism, length times width, with multiple layers, height. Therefore, the formula, length times width times height, is an extension of the formula for the area of a rectangle. The focus of this expectation is for students to understand the concept of volume rather than the formula. Students investigate authentic problems involving volume to make sense of this concept. You will notice that IOA 5A focuses on writing, evaluating, and interpreting simple numerical expressions up to 2 operations involving whole numbers with or without grouping symbols to represent actual situations. This IOA is embedded with IOA 8D as students discover and explain how the area of the base times the height can be applied to find the volume of a right rectangular prism using grouping symbols. IOA 5A is not taught in isolation within this unit. And finally, you will find the new extension IOAs to support the differentiated needs for students. As you can see, the word extension is bolded and in parentheses to notify that these are extensions and are specific to Gwinnett County. Please note you will not find resources from the state of Georgia for these IOAs. The pacing guide is an example intended to model how instruction of the AKS IOAs in each unit may be facilitated. But teachers should design pacing to be responsive to the learning needs of your students. Unit 1 has a suggested pacing of about 4 weeks. You will see on the pacing guide that there are 17 given days of instruction, which includes the Unit 1 assessment. Take note of the bullets on the left side of the pacing guide. These show the learning progression of the AKS IOAs for each unit and suggest manipulatives and tools. For Unit 1, you will need snap cubes and centimeter cubes. You will also need grid paper. Unit 1 opens with 4 days of IOA 8C. Students concretely explore how to determine volume from packing rectangular prisms with unit cubes. Students develop an understanding of the dimensions of a rectangular prism. These concrete experiences are critical in students developing a conceptual understanding of the concept of volume. Students will then progress from concrete to representational by building rectangular prisms when given a volume and counting the number of cubes and layers to find a volume. This prepares students for the introduction of IOA 8D, in which students discover and explain how the volume of a right rectangular prism can be found by multiplying the area of the base times the height to solve authentic mathematical problems. IOA 8C does not include abstract thinking. IOA 8D is introduced concretely using centimeter cubes and/or snap cubes. Students will begin to make the connection between area and the base to discover base times height. This IOA will progress by bridging concrete learning with representational diagrams of rectangular prisms. Representational experiences include determining volume given the base and determining volume with all dimensions given, with and without unit cubes visible. The goal is for students to discover and explain how base times height can be applied to find the volume of a right rectangular prism. As students transition to abstract thinking, they will apply base times height to find volume given a missing dimension and/or all dimensions. IOA 5A is addressed here as students use grouping symbols to write and evaluate expressions to determine volume. On the right side of the pacing guide, you will notice a number of provided resources. Aligned to the bullets on the left side of the pacing guide. Throughout the pacing guide, you will notice different lesson types: traditional, teacher-directed instruction, and task-based learning. For days where a task-based lesson is provided, you will see a blurb above the linked lesson. Additionally, you will see resources that have been pulled from the adopted Georgia Reveal curriculum resource for 5th grade. These resources are not directly linked and can be accessed via the GCPS portal. However, you will also see examples of lessons that have been adapted using Georgia Reveal components. Resources from the Georgia DOE have also been adapted and linked to the pacing guide. Some Georgia DOE resources have been directly linked. The Analyzing the Standards documents, or ATS, provide teachers with an overview of specific instructional strategies progressing from concrete to representational to abstract. The ATS for each IOA is linked to the pacing guide at the beginning of each unit. These can also be found on unit pages on eCom. You may also notice that the ATS has been linked to the top of each lesson plan provided on the pacing guide. We won't be looking at every strategy from Unit 1 in this video. The learning progression for Unit 1 is not linear. There will be times when you might need to connect back to the concrete models when exploring representational and abstract strategies. Let's look at this scenario. Mrs. Fisher is organizing her classroom. She is trying to determine how much space a bookshelf would take up. The bookshelf is 4 feet long, 2 feet wide, and 6 feet tall. How much space does the bookshelf take up? I want to build a model of Mrs. Fisher's bookshelf. I know that the bookshelf would cover an area that is 4 feet long and 2 feet wide on the floor. I'm going to use grid paper to represent the space the bookshelf would cover on the floor. you can see I've counted 4 unit squares to represent 4 feet in length and 2 unit squares to represent the 2 feet wide, the width of the bookshelf. So I have 4 by 2. This represents, again, the amount of space the bookshelf would cover on the floor. But I know that this only represents 2 of the dimensions. So I'm going to use unit cubes to represent the bookshelf. So I'm going to go ahead and put in the base. Again, I can see that it has a length of 4 unit cubes and a width of 2 unit cubes to represent the length of 4 feet and the width of 2 feet of the bookshelf. But again, this is only 2 of the dimensions. Her bookshelf is not flat, so I'm going to use snap cubes to show the bottom or the base, but also I'm going to use snap cubes to show the height, which is 6 feet. I will need 6 layers that have the same dimensions as the base. So I already have 1 layer, and I need 6, so I'm going to add 5 more. There's 2, 3, 4, 5, and 6. I'm going to get those nice and straight. And again, teachers, it always helps to kind of have these built in advance. I'm going to turn it sideways so you can see those layers. There are, in fact, 6 of them. Trying to get it as straight as I can. I want to be as authentic in my modeling for my students as I can be. So now that I have built my model, I need to determine the total number of cubes or cubic units I used to make it. This will tell me how much space, or the volume in cubic feet, of the bookshelf. I'm going to use what I know about area to help me. I know I can find the area of the space taken up by the bookshelf on the floor, or its base, by multiplying the length times the width. So let's look at the base. Our model has a length of 4 units and a width of 2 units. So the area of our base is 8 square units. This means our base holds 8 cubes. Our model has a height of 6 units. So we made 6 layers. Each layer has 8 cubes. So I can use repeated addition or multiply the number of cubes, which is 8, by the number of layers. 6 to find my total amount of cubes. I know that 8 times 6 equals 48. So there are 48 cubes in our model. Since 1 cube represents 1 cubic foot, the volume of Mrs. Fisher's bookshelf is 48 cubic feet. I can write and evaluate an expression to show how I determine the volume of Mrs. Fisher's bookshelf. Since I determine the area of the base using the length and width first, I will group my length and width with parentheses. So let's take a look at what we did. I know that the length was 4 feet long and that the width was 2 feet wide. So I will represent this part in parentheses, and that represents the area of the base, or the bottom of the shelf. I then multiplied the length and the width of 4 and 2 to get the area of the base, which is 8. I then multiplied the area of the base by the height of 6. 8 times 6 is 48. Again, the volume is 48 cubic units for the bookshelf. Let's take a look at another problem. Paul has a wooden planter in his backyard that has a base with an area of 16 feet. He wants to fill the planter with soil to a height of 3 feet so that he can plant vegetables. What is the volume of soil in the planter? So in the last problem, I already had the length, the width, and the height given to me, all of the dimensions I needed to determine volume. And I did that by building the base layer and then adding each subsequent layer to represent the height. In this problem, I already have the area of the base given, and I know the height. But I know that in order to determine area, I would need to know the length and the width, and I don't have those dimensions given to me in this problem. So I know that the area would be the bottom or the base of the planter. So from this problem, I know that the area or bottom of the planter measures 16 square feet. I'm going to use some snap cubes to construct the volume of the soil in Paul's planter. The edges or sides of the snap cubes will represent 1 unit, or in this case, 1 foot. If I use snap cubes to design the base or bottom of the planter, I know that I will need 16 snap cubes, but I do not really know the dimensions. In this case, I could make the planter be any rectangular shape as long as I have only used 16 snap cubes. So let me think about this. I'm trying to think about the factors that when multiplied together would result in 16. I know that 1 times 16 equals 16. I also know that 2 times 8 equals 16. And I know that 4 times 4 equals 16. So that means I could make Paul's planter 1 foot by 16 feet, 2 feet by 8 feet, or 4 feet by 4 feet. I could choose any of these measurements, but I'm thinking a planter that measures 4 feet by 4 feet would be great. So I'm going to build the dimensions 4 feet by 4 feet and fill in the space in order to show the area. This means the base would have a length of 4 feet and a width of 4 feet. I know that the base of the planter already has an area of 16 square feet, in this case, 16 unit cubes. So I've put them in groups of 4, and I know I'm going to have 4 by 4, so let me grab all 4. All right, make sure you can see them. So before I solve, let me think about what I've done. I know that the base is 16 square feet, and so I've used unit cubes to represent that. I know that there are 1, 2, 3, 4, 1, 2, 3, 4 for 4 by 4 for a total of 4 times 4, which is 16. So I know the area of the base is 16 square feet. So I am thinking, okay, how can I solve this problem to determine the actual volume? So I know the area of the base, which is 16 feet, and it has dimensions of 4 by 4. So I can go ahead and record using grouping symbols 4 times 4, and that represents the 16 square feet or the area of the base. If I were to continue building up to represent the entire flower box, I would need to have 3 total layers or a height of 3. I already have a height of 1. But if I multiply that area of the base by the height of 3, I can determine the total volume of soil that can be put in the planter. So I know that 4 times 4 is 16. That represents the area of the base or the bottom layer. And if I multiply that by the height, 16 by 3, that would give me a total of 48. So what does the 48 mean in relation to the problem? So when I go back to the problem, I know that I needed to find the volume of the soil by multiplying the area of the base by the height of the soil within the planter. I can answer the question by writing the volume of the soil in Paul's planter is 48 feet cubed to represent all 3 dimensions. So now that we've looked at a concrete strategy paired with representational, and then we also looked at a problem where the area of the base was given, but not the length and the width, and we use that to determine volume. Let's take a look at what an abstract strategy might look like for AKS, 8C, and 8D in this unit. So let's take a look at this scenario. Mrs. Fisher has a second bookshelf. The dimensions of the second bookshelf are the length is 4 feet, the width is 3 feet, and the height is 5 feet. Determine the volume of the second bookshelf. Write an expression to show your thinking. So again, teachers, this is not a problem or strategy that I would use until students have first with AKS or IOA 8C, I've had the opportunity to do some packing, to really build a conceptual understanding of volume using unit cubes. And then students have also had the chance to really dig into some concrete and representational models to determine volume when all the dimensions are given, maybe to determine the volume when just the base is given, but not the length and the width. So students at this point in the learning progression have really had the opportunity to develop a conceptual understanding of volume and really begin to apply the concept of base times height to really explain how to determine total volume. So here, I'm going to, this is much later in the progression, this is abstract thinking. I'm going to use all of those previous understandings to determine the volume of the second bookshelf. So I know that the length and the width represent the base of the bookshelf. So if the length is 4 feet and the width is 3 feet, I can multiply these together to find the area of the base or the bottom layer of the bookshelf. I'm going to use grouping symbols to represent the area of the base. I also know that the bookshelf, the second bookshelf, has a height of 5 feet. This is the same as saying it had, if we were using unit cubes, this would be the same as saying it is 5 layers. So I can multiply that by 5. So again, the area of the base, which is the length times the width, using those grouping symbols, because I'm going to do that part first, multiplied by the height will help me determine the volume of the second bookshelf. So I know that 4 times 3 is 12. So I know that the area of the base is 12. If I multiply the area of the base by the height, that will help me determine the total volume. I know that 12 times 5 equals 60. So let's look back at what units I used, because I always want to make sure that I include my units when I'm talking about volume. So in this case, the bookshelf was being measured in feet. So I know that the volume of the bookshelf is 60 feet cubed. That shows that it is in fact a 3-dimensional object. So teachers, in this case, you did not see me use a representation of the bookshelf or use a concrete model of the bookshelf. If students still need that, I could have built the bookshelf using unit cubes and then determine the total volume. So like I said earlier, there might be times when you might need to connect back to concrete models when exploring a representational and an abstract strategy. In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. So when I'm thinking, so which strategy? Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. Thank you for watching. please use your phone to scan the QR code on the screen or go to the website shown to get your completion credit in PD&E.